Hello, ladies and gentlemen. Root Beer here, looking at the last question, question 25, on our 2011 Pascal paper. Dolly, Molly, and Polly can each walk 6 kilometers per hour. Their one motorcycle, which travels at 90 kilometers per hour, can accommodate at most 2 of them at once and cannot drive by itself. A reasonable assumption. Let T hours be the time it takes for all 3 of them to go 130 kilometers away, reach a point that's 135 kilometers away. Ignoring the time required to start, stop, and change directions, what is true about the smallest value of t? And then if we look at our answers here, we're given a range of values. So t looks like maybe it could be as lower than 3.9 hours, or in worst case scenario, it's more than 4.5 hours. Okay, that's what we're looking at for our possibilities. Could be some range in between. So it's up to us to first sort of try and think through the question, what is going to get these 3 girls down 135 kilometers away, 135 kilometers down the road, in the smallest possible time? What's the most efficient use? Okay. So it's a good idea to play around and imagine things. So here I'm going to put Dolly, Molly, and Polly, and we've got 135 kilometers. Okay? So sort of a really simple, basic way to at least get everybody down to the end is to have Dolly take Molly on the motorcycle, go 130 kilometers down the way, and then we got Dolly and Molly here. And Polly's just waiting. Okay? So they head off that way. Now Dolly's going to come back 130 kilometers again. Eventually she'll reach the end and collect Polly, and Molly's just waiting here at the end. And then Dolly and Polly on the motorcycle come back one last time. And Dolly, Molly, and Polly are now at the end. So what's happened? Dolly on the motorcycle has gone back and forth and back and forth. So we've gone 135 kilometers, a total of 4 times, and the motorcycle, we're told, moves at 90 kilometers per hour. Okay? So you can just grab your trusty calculator, 135 times 4. Divided by 90, that would give me 6 hours. That's a 6-hour trip right there. Dolly, Molly, and Polly, but everybody's gotten to the end. So right now we have an answer, and it looks like it's E. Okay? But is that the smallest possible t? And here's where it can get tricky. How do I know I definitely have the smallest, that there isn't a better improvement? Okay? Well, we can start improving it right away. Okay. I'll start Dolly, Molly, and Polly over here. Now, you'll notice when Dolly and Molly are driving towards the end, Polly is just sitting here waiting to be picked up. Surely Polly could move a little bit as well. Right? So Dolly and Molly are going to move, but so is Polly. And so by the time Dolly and Molly get down here, so Molly gets dropped off, and then Dolly will turn around and come back, Polly has been walking at 6 kilometers per hour. So Polly's made it some distance. Polly's now about here. And we can keep Polly walking, and Dolly's coming back towards her, and then they'll meet about here. Molly's just sort of twiddling her thumbs, waiting at the end, and then they keep going, and now everybody's back here. Okay? But Polly hasn't been wasting. Polly's been moving towards the end as well. Okay? And we can work this out. How long does it take Dolly and Molly to get to the end here? Well, they'd have to go 135 kilometers at 90 kilometers per hour, so it takes them 1.5 hours to get here. Okay? And in that time, Polly will have walked 9 kilometers. Okay? Then Dolly turns around, and 90 kilometers per hour is heading back towards Polly. And there is 135 minus 9 is 126 kilometers between them. But we can keep Polly walking as well. And so this gap between them is decreasing at 96 kilometers per hour. So how long does it take them to meet? 126 divided by 96. They'll finally meet after 1.3125 more hours. And in that time, at 6 kilometers per hour, Polly has managed to walk 7.875 more kilometers. So now how much space is there between them and the end? 126 minus 7.875. There's 118.125 kilometers between them. They're traveling at 90 kilometers per hour because now they're both on the motorcycle. Another 1.3125 kilometers. So add that to our previous 1.3125 and 1.5 hours. And in total, we've got 4.125 hours. That is a vast improvement. 6 hours. Okay? So now we know the answer can't be E or D because we've got an improvement. We've got something that's sitting at 4.1 something hours. Right now our answer looks like C. So if somebody called time, I would quickly bubble in C because that's my best guess. Okay? Now how did we improve? Think about how did we improve? We're doing better because Polly isn't just sitting around waiting. Polly is moving. Okay? But we left Molly at the end. The best time you're going to get, and you can convince yourself of this, is a time when someone is always on the motorcycle, because that's fastest, but where everyone is moving. Okay? We improved because Polly was not moving at 0 kilometers per hour. Polly was moving at 6 kilometers per hour. Polly was getting towards the end at her best possible speed. You say, okay, but how do I get Molly to move? She's already at the end. Here's an improvement. Here's, in fact, the best improvement we could make. We've got Dolly, Molly, and Polly. Dolly and Molly get on the motorcycle. They start moving. Polly moves as well. Dolly and Molly reach some point near the end, okay, but not at the end. And Molly gets dropped off. Now, in this time, Polly has moved a certain distance. Dolly heads back. Polly keeps going forward. Molly starts walking, and Molly's going to keep walking. Eventually, Molly will reach the end. And we're going to make it. We're going to pick this drop-off spot so that Dolly, Molly, and Polly all reach there at the same time. Because if Polly got there, if Molly got there first, we could have dropped Molly off a little bit further back. And if Dolly and Polly beat her, then we probably should have dropped Molly off a little later. We want them all to get there at the same time. So we'll have to work out where this drop-off spot is. Okay. So Molly gets dropped off. Dolly and Polly race towards each other. Polly goes a little bit of distance, but then they meet. Okay. And then they start heading this way as well. And then suddenly they're all together at the very end. Okay. So now the question is, well, okay, where does Molly get dropped off? What's the time frame on here? Because if I don't know where Molly's going to get dropped off, I don't know how long it's going to take Dolly and Molly to reach this point. I don't know where Polly will be. Then I don't know how far between Dolly and Polly. So I don't know how long till they meet. So we really need to sort of nail down a time here. So we're going to call this X. Or not time. We need to nail down a time frame. So let's just call this X kilometers. So Molly gets dropped off X kilometers from the end. And then she walks. Okay? Now, there's an interesting little observation that I want to make. There's a great deal of symmetry. Let's rewind this. Okay, let's rewind this. Dolly and Polly are going to go backwards. And Molly's going to start walking backwards. And eventually Dolly and Polly, if we're just imagining this scene in reverse, eventually Polly hops off the motorcycle and starts walking backwards, and Dolly comes towards Molly. And then eventually Dolly and Molly meet. Polly keeps walking backwards. Molly hops back on the bike, and eventually they all meet. But we're going in reverse. But you'll notice it's the same steps. 2 people on the motorcycle, somebody dropped off, then the motorcycle meets the other person, and they're all at the end. It's the same backwards and forwards. So here's an observation we can make. When Dolly and Polly meet, by symmetry, they must be meeting X kilometers from where everybody started. Okay? Just an innocent little observation. Okay? But it certainly is not immediately obvious. Now, let's start working things out. I'm going to get a clearer picture. Okay? So this distance x, that's where Molly gets dropped off. That means that the time it takes for Molly to go here is 135 minus x over the speed of the motorcycle, not motorbicycle, motorcycle. So 135 minus x over 90. Okay? So Polly has gone some distance. What distance? Walking speed of 6, then 135 minus x over 90, the time, the frame that we're looking at. Of course, 6 and 90 cancel out. We got 135 minus x over 15. So that's how many kilometers Polly's already walked. Okay. Now Dolly and Polly start racing towards each other. Okay. How much space is between them? Well, we know from the start to where Dolly is currently, it's 135 minus x, and we know how far Polly has gone, a 15th of that. So what's left? 14 fifteenths of 135 minus x. Okay? And they go at that speed, again, at a combined, they go that distance. That distance shrinks as Dolly and Polly get closer at a combined speed of 96 kilometers per hour. So that's how long it'll take. So it'll be 14 over 15, 135 minus x, all over 96. That's our new time. I'll put times in green so we don't get confused. And that's how long till Dolly and Polly meet. And I can tell you they must meet x kilometers there, because x kilometers from the start. Okay? And in the meantime, Molly has been walking. And now Dolly and Polly race towards the end. But we know, by symmetry, it's going to have to be 135 minus x kilometers that they travel for everyone to meet. Okay? So that can tell me the total amount of time. I know this last leg of the journey, 135 minus x over 90. Okay? But I also, because we need to somehow solve for x, and all we're really doing is adding up these three time frames, or these 3 times, to get our t. But how do we actually work out what x is? Well, the key is Molly. I need Molly to hit at the end, to get to the end when Dolly and Polly get there. Okay? So Molly travels x in the time it takes for Dolly and Polly to meet, and for Dolly and Polly to get to the end. And we know how fast Molly goes. She travels at 6 kilometers per hour. So this remaining leg of the journey takes x over 6 hours. Okay? So we can get a nice little equation. So 14 over 15, 135 minus x, plus 135 minus x, well, we could say 1/90th. 135 minus x. This has got to be the same as x over 6. These last 2 times add up to x over 6. And now I'll be able to solve for x, and then I should be able to get t. And I know it'll be the most efficient t because everybody has been moving. Okay? So I'm going to multiply by 6 on top and bottom. So I'll change this to 90 and 84 on top. And I'm going to multiply by top and bottom by 15 here, so 15x over 90. And now I can get rid of the 90s. All right? And now over here I've got 85, 135 minus x is 15x. So 135 times 85, which we'll grab our calculator for. Still on erase mode. 11475 minus 85x is 15x. Bring the 85 over to the other side. 11475 is 100x. And so now I know where x is going to be. Let's divide by 100. So we get 114.75 And that should be our value of x. Now, hold on, that doesn't quite make sense. Oh, I forgot the divide by 96. Okay. That was weird, because I was going to have too big a number. So really, we should still have a divide by 96 here. So I think it should be something small, like, I don't know, like 10 or something. All right, so let's clean things up. We still multiplied by 90. So everything's still fine, but now let's multiply by 96 on both sides. And then 15 times 96, that's 1440x. 96 plus 84 is 180. So we get 180 times 135. 24300 minus 180x is 1440x. 1440 plus 180. We get 1620x. I can at least divide both sides by 90. I'll get 18x, 243 divided by 9. We'll get 270. I can divide both sides by 9 again. So I'll get 30 is 2x. And so I see x is 15. Okay. So Molly gets dropped off 15 kilometers from the end. Polly happens to be picked up 15 kilometers from the beginning. Again, that was a symmetry argument, as the scene played the same forwards as backwards. Okay? Great, now I know what x is. If I add up these 3 times, I should get the smallest possible t, because everybody's been moving. Okay? So it's been sort of a lengthy question so far. Remember, I'm also trying to teach, I'm trying to explain the symmetry and explain the different possible arguments that you might think of before you stumble upon the right one, and why to realize that this is the best one, because everybody's moving if they can. Okay, so we've got t is 135 minus x over 90. 14/15 all over 96, 135 minus x. And then another 135 minus x over 90. Well, we plug in the x, and this turns into 120. Same with this one and this one. So 120 over 90, that's 4 over 3. 4 over 3. 20 and 15, that's 8. 120 and 15. 96, you can divide by 16. So I should get 7 over 6. Okay. I'll just quickly double check that. Don't want to have the wrong calculation at the very end. Nope, we're good. And then 4/3 plus 4. Actually, you know what? We can put it all over 6. So this is really 8 over 6, 7 over 6, 8 over 6. And so that's what, 23 over 6, which, since everything's in terms of decimal in when we come into the answers, that's going to be just a little under 4. It's 3.833 and so on. And what range does that fall into? That's in the lowest range. So we don't even need to guess, is there a smaller one? Even if there were, it would still give us the answer of A, because it's the smallest possible range. Okay? So there we go. So you can work it out. I don't believe you actually need to notice the symmetry, but it does make the question a little bit longer. Okay? And in case you are wondering, yes, this is the optimal solution. You can't really do any better. Even if we could, we're in the lowest possible interval, so we'd get the same answer of A anyway. Okay? So that wraps up our 2012 Pascal paper. Thank you guys so much for watching, and I'll see you for more math in the future. Until then, take care.